So this continuous rainbow pattern with dark bands was termed a dark line spectrum, or a line absorption spectrum. Bohr concluded that the unexcited gas must only be able to absorb certain photons and not the entire spectrum. This supports Planck's Planck's hypothesis that matter is quantized. Because each would only have its certain wavelength. So the lines represent what was being able to be absorbed. Okay? So this gas could only absorb this, 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 and this. Because think about it like that's the gas like blocked those photons out because it absorbed them, and so what continues through is left. So next, Bohr modified the experiment slightly and passed light given from a glowing / excited gas. So a gas that is energized by some form such as heat through a prism or a grating. This time, Bohr observed that no continuous spectrum was produced, but only thin bands of certain colors were produced. So this, look at now, only certain colors are shown. Okay? This is an emission spectrum. So here, this spectrum was called a bright line spectrum, or a line emission spectrum. Bohr concluded that the excited gas must only be able to emit certain photons, just as cooled gas can only absorb certain photons. So now, look at your absorption spectrum and your emission spectrum. You have it on the same page there. If it's the same gas, look at the absorption spectrum where the dark lines are, should be where the bright bands are on the emission spectrum, right? Because if this is absorption, okay, if the dark bands show where it absorbed, okay, then the emission spectra should be the opposite and show where it emitted. Okay, so it's like meaning that gas only has a certain photon that it can absorb and emit. But this would be like that only happens if it's the exact same. Yes. Okay. Bohr also discovered. Oh, did I miss a part? Yeah. There. Thank you. Bohr, both atomic spectra, line absorption, and line emission help Bohr explain that atoms of a particular element can only absorb and emit photons with certain wavelength frequencies or energy. If an element can only absorb certain photons, it makes sense that the same element can only emit those same photons. Okay? So it depends on if the gas is excited or cooled, is if it releases energy or absorbs energy. So think about it. The cold gas made that absorption spectra, okay? It absorbed energy. the emission spectra was the hot gas and it released energy. So here you can see, here's a hydrogen absorption spectrum and the corresponding hydrogen emission spectrum. Make a note to yourself here, wherever there is a dark band in the absorption spectra, there should be a color band in the emission spectra of the same gas. So wherever there is a dark band in absorption, the emission spectrum of the same gas will have bright lines where there were dark in absorptions. So now, Bohr discovered that every element has its own unique spectra. So this is, say, the one for aluminum. Well, that looks quite a bit different than hydrogen. Bohr needed to revise the model of the atom to explain why matter is quantized and can only absorb or emit certain photons. So now this is where we are really going to start connecting our knowledge of chemistry with physics. The rest of this unit will have a lot of chemistry in it, okay? Because Bohr proposed that within the atom, there are certain allowed energy orbits. Around the nucleus in which electrons can move and orbit without giving off energy. Now, do you remember back to chem where we would have like, okay, 2 electron, 8 electron, 7 electron, you know, and we would make our orbitals? That's Bohr's model. Okay, so it's explaining why he made this model. So crazy, because they couldn't just all be going around on the same orbit because they'd all collapse together because there's no way for them to emit or absorb photons. But if I jump down or jump up, I can release or absorb energy between these energy levels. That's how it makes sense. I'll show you lots more examples, but it's cool because it explains why we use that chemistry model to understand how we make an ion, how we have an atom, and everything. This meant that the energy of the electron in an atom is quantized. Just as Planck hypothesized, for the electron to occupy any one of the allowed energy orbits, it must possess the energy allowed for that orbit. Electrons cannot be found between orbits, so it must possess the energy for that orbit. When an atom absorbs a photon, the electron in the atom will move up. Okay? So think as you go up the energy levels, you go up in energy. Okay? So if you absorb a photon is energy. When an atom absorbing a photon corresponds to a dark line absorption. Really important, okay? Really important that you connect those ideas. Because if you think about it, you're absorbing a photon, you're absorbing energy. So it's like a gas that absorbed that energy and kept it for itself, so that stays with the dark line spectrum. When an atom emits a photon, the electron in the atom will move down to a lower energy orbit. An atom emitting a photon corresponds to bright line emission. Okay? So really, really, really important that you connect these ideas. Okay? So, yeah, and we're just going to keep doing chemistry. It's going to be exciting. You're using all your knowledge from Chem 30. Well, parts of it. Okay, so if we think about this, including our knowledge of chemistry and physics, so say here's my atom, okay, and say a photon comes in, okay, so this wave is representing a photon, and it has a certain amount of energy based on its wavelength, okay, so its wavelength is like its property, okay, so it has a certain amount of energy coming in. If that energy comes in and hits that electron, okay, it can bounce it up to the next level. See how it bounced up? Okay, so this is atomic excitation, or this is the absorption. So here we can see the electron moves up, okay? Therefore, if ever we see that a question says the electron moved up an energy level, you can assume then that that means that a photon is absorbed. Which should also indicate to you that you need to look or think about an absorption spectrum. Okay, for this one. So if this situation happens, these are the assumptions that you can make. It's really important that you can connect this event to these conclusions. Okay? You don't necessarily have to memorize them, because if you understand it, you don't have to memorize it. You can just think for yourself, but you need to make those connections. Now here, what happened? Who's there?